Hi. So let's start with the revision of our first chapter, sets, relations and functions. Now, consider these two notations. Now, both the notations contains the elements 2 and 3, right? But the first one is in the curly brackets and the second one is in the round brackets. The curly brackets indicate that it is a set, whereas the second round brackets indicates it is an ordered pair. Okay. Now, the set contains two elements 2 and 3, whereas the ordered pair itself is a single element. Okay. Now, let us have a look at where it is used, where the ordered pair is used. Consider these two sets A and B. Now, if we need to multiply two sets or find the Cartesian product of two sets, then what we need to do is we need to take the first element from set A, that is 2, and put it in the ordered pair with the first element of set B, that is A. So, the first element will be 2A. Similarly, the first element of set A with the second element of set B, that is 2B, and the first element of set A with the second element of set B, third element of set B. So, that will give you 2C. Similarly, as we did with the first element, the same thing is to be repeated with the second and the third elements as well. So, the next three terms will be 3A, 3B, 3C, and the next will be 4A, 4B, 4C. So, this is how you multiply two sets. Now we'll move on to what is the relation between two sets. Now, if I take any number of elements from this set, from the Cartesian product, okay, suppose I take these three terms from the Cartesian product and make another set. So, this set is called as a relation between A and B. Okay. So, what is a relation? It is a subset of the Cartesian product of the two sets. Now, let us see how it is represented graphically. Okay. Now, in this, the first set is the set A and the second set is the set B. Now, we will put on the arrows where they are related. For example, 2 is related to B. So, 2B will be one of the arrows. 3 is related to C. So, 3C is one of the arrows, and so on. So, this is how we represent a relation graphically. The first set is called as a domain, whereas the second set is called as the range. This is a relation. Now, moving on to the next thing, that is a function. Now, this is the most important thing in this chapter. What is a function? We'll first look at the definition. A function is a special type of relation in which each element in the domain is uniquely connected to the elements in the range. Now, in this definition, there are two words which are very important. One is each element and the second is uniquely connected. Now, why is that important? We'll look at the example of a function. This is a function. You can see all the elements in the domain are connected, right? No one is left. None of the element is left in the domain. So, that is what is called as each element is connected. Whereas, all the elements are connected uniquely to these elements in the range. That is uniquely connection. Okay. So, this is an example of a function. We'll take a look at few relations and we'll identify whether each relation is a function or not. Okay. Look at this first example. The first example, you can see one of the element in the domain is remaining. It's not been connected to the element in range. So, it is not a function. Whereas, in this example, you can see all the elements are connected, right? So, we can say it is a function. We don't have to worry about the elements in the range. We just have to worry about all the elements in the domain. Okay. Look at the next example now. In this example, is it a function? No, it's not a function. Just because one of the element is connected to two elements in the range, right? So, that is not unique connection. Whereas, in this example, we can see one of the element in range is connected to two elements in domain. That is fine with us. We are just concerned with the elements in the domain, not in the range. Remember this. So, this is a function, whereas this is not a function. Okay. Now, let us look at different types of functions. The first one is a very simple thing. It's a 1-1 function. Okay. Each element is connected to one element. That is called as 1-1 function. Whereas in this example, you can see more than one elements are connected to a single element. That is many-one function. Okay, so this is one function, whereas this is many one function. What is an onto function? An onto function is a function in which none of the elements in the range are remaining. You can see all the elements in the range are covered, right? So first of all, it is a function, and as none of the elements are remaining in the range, it is an onto function. Whereas in this example, you can see there are two elements which are remaining. So this is called as an into function. Okay, so these are the four basic type of functions which we will study in this lesson. Another very important thing which we are going to study is composite function, a function within a function. Let's have a simple example. Suppose there are two functions, f of x and g of x. Now what we have to do is, if we have to find a composite function on f and g, f of g, that is represented by f of g, what we have to do is we have to replace all the x in function f with the function g of x. So once I replace this is how we solve. And finally, the answer which we get is a composite function. Okay, we'll look at the second example, f of x and g of x. Again, this time you have to find g of f. Okay, now wherever you find x in the function g, I'll replace it by f of x. So this is how you solve. And finally, after solving, if you get the answer x, so that function g of x, that function is called as an identity function. So these are some basic things in this chapter which are to be remembered.